Hi everyone, so I'm here again to do another AP Physics C free response. This one is a 1988 Electricity 2. So the diagram on the paper I just redrew over here, and the question reads, in the circuit shown above, the battery has been connected for a long time so that the currents have steady values. Given these conditions, calculate each of the following. A, the current in the 9 ohm resistor. So again, I redrew the figure here, and yeah, it's the circuit shown above, and the battery is connected for a long time. So part A, they want to know the current in the 9 ohm resistor, which is right there. Okay, so to find that, we're going to have to calculate the total resistance. So we'll start by, hold on, I just have to find my marker. Okay, so part A. So first we have the series over here, the 8 and the 4. These two are in series. So right here, that for the resistor in that series, you simply have to add them. So we'll have the resistance of 8 plus the resistance of 4. So the 8 ohms plus the 4 ohms equal 12 ohms. Okay, and if you didn't know that that was a series, there's a trick that someone in my class actually told us. They said to label wherever the current starts with A and wherever it leaves with a B. So if I made here an A and here a B, and then again here with A and here with B, you can see that if it goes from B to A, it's a series. But if I were to go here, A, B, it would go from A to A. So it's in these two are in parallel. And again, because this goes from B to A, it's a series. So that's just a trick if you wanted to know. Okay, so we have these two added up. Now we're going to do the parallel. So we'll have this line, which we calculate added with this line. So then for parallel resistors, you have to do the reciprocal. So 1 over R parallel will have 1 over 12 ohms, which was the added right here, plus 1 over 4 ohms. And this added together be 4 over 12 ohms, which is a third, 1 over 3 ohms, and because you have to reciprocate it, it would turn out that that R would equal 3 ohms. Okay, and again, now we have this one, and all of this added together, plus that one, they're going to be in series. So again, for series, you simply have to add them. So we'll have, again, our series would equal the 3 from here, so 3 ohms plus the 9 ohms equals 12 ohms. Okay, so this is a total number of ohms for the entire circuit. Okay, so now the question again was the current in just this resistor. So to find that, we're going to go to V equals IR, which is basically the potential equals the current times the resistance. And then we'll just solve for I. So we have I, which is the current, is V over R. The V over here is 120 volts. So 120 volts over the resistance, which is 12 ohms, gives us 10 amps. So that is the current in that resistor. Okay, so now part B. Part B says the current in the 8 ohm resistor. The 8 ohm resistor is right there. So now for this one, what we're going to basically do is we want to find the V first. So we'll have V equals, because the voltage here is going to go, it's going to split in two lines. So this one's going to vary. So we'll have that the voltage equals the voltage of the 8 plus 4, which is these two. So 8 plus 4. And that basically equals that parallel line over here. So we have V parallel. Oops. I don't know how to spell. Anywho, okay, and that's going to equal, the parallel we set over here is going to equal 3 ohms. It's going to be the series plus parallel, which is 3. So 3 ohms times the amps that we figured out here. So times 10 amps gives us 30 volts. So that's how much basically goes in that line of the circuit. So now we're going to have, again, I equals V over R. And that will basically be the 30 volts over, because we want to know the current in this resistor, we have to add up these two. So I have 30 volts over 8 ohms plus 4 ohms, because they're in series we can just add, don't have to reciprocate. That's going to be 30 over 12, 30 volts over 12 amps, which gives us over 12 ohms I meant, which gives us 2.5 amps. So that's the current in that resistor. Okay, moving on. Part C. Part C reads the potential difference across a 30 microfarad capacitor. Microfarad capacitor is right there. And now for this, we basically, again, we could just use V equals IR. So you have V equals IR. And the I, which we found right here, is 2.5 because the capacitor's in this line, equals 2.5 amps times, and then we want the resistance, which is in this capacitor, is 4 ohms, so times 4 ohms, and that gives us 10 volts. And that's basically it. That's all we need for the voltage, or the potential difference. And now we have part D, which is the energy stored in this 30 microfarad capacitor. So now for energy, we'll have U equals 1/2 CV squared. That's the formula. C is capacitance, V is the potential. So we have this equals 1/2 capacitance, which is 30 times 10 to the negative 6 farads, because it's 30 microfarad capacitor, times the voltage, which is 10, which we found right here, 10 volts, squared. This, when it's all solved out, will give us 1.5 times 10 to the negative 3 joules. So that's our answer for the energy. Okay, now the last part says, at some instance, the connection at point P fails, and the current in the 9 ohm resistor becomes 0. E. Calculate the total amount of energy dissipated in the 8 ohm resistor after the connection fails. Okay, so now, because the resistance in the R has gone to 0, we can tell that the total energy is going to be, the energy in the 8 ohm resistor is going to be a fraction of the total. And because right here we can see that there's 4 resistors, there's 1, 2, 3, 4, the energy, you already know, E. The energy in the 8 ohm resistor is going to be 1/4 of the total energy times, you basically want to do resistor over both of these added together because they're in series. So we'd have this times 8 ohms over 8 ohms plus 4 ohms. Because that's only it's like a ratio, it's the only part of it that we want. So when this is solved out, we get 1/4 times 2/3 of the total, which is 1/6, because 1 cancels to 1/6 of U. So we have 1/6 times the U we found here, which is 1.5 times 10 to the negative 3 joules. And that gives us 2.5 times 10